Yeah, here you see Captain Sandy Friedenthal in the middle and his crew. This picture was taken around 2015 in a workshop when we were already working on SysML v2 a long time ago. And here you can see some of the people involved, mainly tool vendors. You see Nomagic here, IBM, Tom Sawyer, PTC, Aras, and so are here on this picture. Yeah, the next picture was taken December 2019. There were already a few more of us. And this was the last workshop before Corona in Long Beach, in Los Angeles. And this picture and the last picture was taken 2 years later in the same hotel in Long Beach in December 2021. So as you can see, times have changed. And the people, yeah, there were not so many people there due to the travel restrictions. Yeah, so our plan is we have almost 1 hour time to talk about SysML v2 in general, the overview, motivation, and then we will have a look on some of the features. Of course, not all of them. That's not possible in an hour. And that's my time buffer. At the end, if we have some time left, I will do a brief demo. At least I will show you how you can do the demo yourself. Yeah, Tom already mentioned, I'm from OSE, consultancy and training company from Hamburg. So this is not for marketing reasons, but that you know the context. But of course, you can also book me if you like. And that's me. So yeah, I wrote many books about modeling. That's my passion. And I'm one of the developers of SysML v2. So I'm a member of the team. And I'm also one of the developers of SysML v1. I'm one of the co-chair. Actually, there are 2 chairs who are responsible for SysML v1. And we work on v1.7 at the moment. Yeah, so that's me. Let's start with SysML v2. That's more important. That's why you are here. Yeah, that's a big challenge in front of us, or we are already in there, to develop the next generation modeling language for systems engineering. And it's a language for, well, at least the next 15 years or so, roundabout. It will be published in a few years. So probably next year or in 2 years or so, roundabout. And then it lasts typically around 10 years that the industry adopted a new standard. Yeah, and then maybe then after 5 or 10 years or so, we go the next step. So it's a long time. Responsible for SysML is the OMG. The object management group is also responsible for other standards like UML, MDA, so the model-driven architecture, BPMN, and so on. So also many domain-specific stuff. That's the roadmap of SysML v2, and well, it started in 2009 when the OMG published a so-called request for information. It's a questionnaire to the industry where they asked questions about, are you satisfied with SysML v1, what's missing, and what you expect from a systems modeling language, things like that. And then a lot of working groups worked on the responses, but also on things they know from the communities. And finally, in 2017, the OMG published the request for proposal, so a list of requirements for the SysML v2 language. And the plan is that the implementation of the SysML v2, the specification, will be submitted this year in the 3rd quarter. That's the plan. And we are here in between. And we are the SST team. That's the SysML submission team. That's the group that works on the SysML specification. And this group works outside of the OMG. The OMG is responsible for the RFI and the RFP. And now the OMG waits for the submission, or for many submissions, but there's only one. And then the OMG adapts the submission, hopefully. And then it takes some time until they publish the final official publication, specification. And this could last at maximum 2 years. And during that time, the OpenG finalization task force works then on this task. Maybe it's only 1 year, but at maximum it's 2 years. So we expect SysML v2 in 2023 or latest 2024. Yeah, the SST team is a large group of people, 201 people in the group and 81 organizations. That's a lot. From academia, tool vendors, government, end users, and so on. Of course, not all of them are active. Some of them are, well, probably are only on the list. Some of them are observers, and some of them are partly active. And there's a core team that continuously works on SysML v2 now since, well, almost 10 years. And the SST team is divided in 6 tracks with track leads. We have a project management track that manages this team. That's at Seidewitz and Sandy Friedenthal, so our captains. Sandy is also the lead of the requirements track, where they evaluate the requirements and look if there are more requirements from the industry. So many industry people are in this track, and they provide their requirements to SysML or for SysML. Then we have a transformation. Transformation from SysML v1 to SysML v2 is another track where I'm a co-lead together with Yves, Bernard. Then we have the track 4, the core team. That's the meta model development. That's where the language is developed. Then we have an API team, and finally, a pilot implementation of SysML v2. Yeah, so why do we do that? Well, there are several new challenges for SysML or for MBSE projects, and we have several old problems. And some new challenges are the digital thread. We have artificial intelligence for systems engineering, which requires a solid database. We have the digital twin. Simulation is getting more and more popular in systems engineering. We have model-based product line engineering. Model interoperability is a big challenge. We switch more and more from drawing to real modeling, and then it's important to have very precise models. In particular, if we would like to do simulations or artificial intelligence stuff. And then I have some examples of issues we have in the current SysML1. There are, for example, wrong relationships, so in the wrong direction. And that cannot be resolved because it's based on UML. We cannot change UML anymore. There's an unclear semantics if we work with real physical stuff. Now, SysML is based on UML, and UML comes from the software domain. But what does it mean if really water flows through a system? Then on one side, it must increase, on the other side, decrease, things like that. Or that's also a typical issue in SysML1 is the integration of structure and behavior. Right? You can perfectly model structural stuff with BDDs and IBDs, and you can perfectly model behavior stuff with activities and state machines. But if you would like to bring them together, then it's a little bit tricky. For example, to map an item flow through the structure to a parameter of an activity, things like that. Well, and of course, the systems engineering modeling language of the future should not be based on a 30-year-old modeling language. UML is 30 years old and is created for object-oriented software development. Of course, there are some issues. There are some problems in the foundation of the language. So UML is not bad, of course. It's very, very good. And we reuse many of the concepts that is inside UML, what we've learned in the SysML v2. But it's not a solid basis. So let's have a look on the SysML v2 features. So first, this here is SysML v1, and SysML v1 is based on UML. It's like a dialect of UML, and a big change is this. SysML v2 will not be based on UML anymore. That's not so important for the end users, so for the modelers, but of course for the tool vendors. And for the tool vendors, this is a really, really big change. So I assume that they hardly can refactor their existing modeling tools for System Lv2. I think they have to create complete new ones. So, or at least it's a very big change of their modeling tools, so, and a big investment, of course. So System Lv2 has nothing to do with UML anymore. The core of System Lv2 is Csml. Csml is the kernel modeling language. It's simply said a modeling language for modeling languages. It's a toolbox to create modeling languages. And here it is used to create System Lv2. And Csml is also created in the SysML submission team. So it's a complete new kernel modeling language. And there are already the idea and discussions around that Csml maybe will be also the foundation for a UML version 3 in the future. But that's long, long in the future. So we have Csml, we have System Lv2, and then extensions around. Of course, you can customize System Lv2 the same way you can customize System Lv1, or conceptually the same way. The mechanism is another one, but you can add your own extensions to the language, methodology dependent stuff, domain specific stuff, whatever. Yeah, let's have a closer look on that. Maybe some of you are familiar with this 4-layer architecture that's also valid in System Lv1 and UML. So here can you see how the architecture of System Lv2 looks like. We have Csml on the left side. We have a Csml meta model that's like the UML meta model. And we have the System Lv2 meta model. That's separated. So Csml is very common, independent of systems. And the System Lv2 meta model contains systems engineering specific stuff. Now, you can use Csml also for UML. You could also use it for BPMN, so for business stuff, whatever. And then on the next level, and that's the level where also the user model is, so your models about whatever. On that level, we have a set of libraries. We have a Csml library that adds some semantics. We have the System Lv2 library, and we have domain libraries, for example, for units. That's a domain library, or for risk analysis stuff. And we have the user extensions. That's then your own specific extensions of the language. So that's a large difference to System Lv1, that we have a lot of stuff on this M1 level in libraries. In System Lv1, most of the stuff is on the level M2. Here's a simple example. So at the bottom, you see a vehicle. And that could be your model element. It's a part definition. It's like a block in System Lv1. And this vehicle is a specialization of the part, which is an element of the System Lv2 library. And this specialization relation or generalization relationship here typically happens in the tool in the background. So you do not care about that. Right? You create your part definition vehicle, and the tool in the background creates this relationship and links it to the System Lv2 library, which provides then the part definition semantics to your element. And then this part is also linked to other elements in the library, which is finally linked to an element in the Csml library. And then on the meta model, we have the elements that provides the abstract syntax, so simply said the data structure of the language, and there we have also part definition and other things. But everything above the user model happens in the background of the modeling tool. So you must not care about that, but it's good to know that it's there and how it works. For example, if you do some queries, if you really go into the data structures, then you must at least a bit know how it works. Another big change is that System Lv2 provides a textual notation. So here's an example. We have a package, and inside the package, we have a part, electrical vehicle, and the part contains a list of other parts, a body, a battery, engine, and so on. So this is a textual notation. And of course, we still have the graphical notation. This graphical notation, the diagram here is taken from the pilot implementation, and it's automatically created. So I cannot change it, have no influence on the layout, and I cannot use it as an editor. But in the future, of course, we expect that modeling tools provide also graphical editors. But if you already have seen the pilot implementation and worked with it a bit, there you can only edit the model by using the textual notation. Yeah, looks quite similar to SysML v1, but there's a big difference here. So if we model the same with SysML v1, then it looks like this. And the difference is that here in SysML v1, we have the blocks. We have a block wheel, we have a block engine, we have a block axis, and so on. And at the association ends, there we have the parts, a front wheel, front axis, rear axis, and so on. These are the parts. So in SysML v1, we always create blocks to define something. And then when we use it, we have the parts, the part properties. In SysML v2, in my example here, we only have parts. So it's like modeling in SysML v1 part properties without any blocks. There is no block here in my SysML v2 example, or part definition is the SysML v2 name. And we can define a substructure of a part. So it's not the end like in SysML v1. I can define substructures. Now I have here a part E vehicle, it's like a part property in SysML v1, and then define a substructure. So that's a big difference. It is also called usage-oriented modeling because I can focus on the usage of things. In SysML v1 is you always have to think about the definition of things first. Now you must define the blocks and then you use it. And in particular for non-software people, it's quite confusing with this block part stuff, BDD, IBD difference thing. So, and in SysML v2, you can focus on the usage level where you use the things. Now that's the engineer level. Now you have things on your table and plug them together. That's called usage-oriented modeling. However, SysML v2 also knows definitions, and much more consequently than SysML v1. So we have the definition of things and we have the usage of things. In SysML v1, we have blocks and parts, or we have activities and call behavior actions. So there we also have this definition and usage level. The usage level is typically when you have the colons, something colon something. That's the usage level. But it's not so consequent as it is in SysML v2. And here I extended my example. On the left side, you see, again, the part E electrical vehicle with all the other parts. But I created a part def, which is similar to a block of the wheel. And you can create part defs if you would like to create something for reuse. So now I have a structure for a wheel, very simple. It just has an attribute. And then I can use it. And you see this at the bottom, my front wheel, colon, wheel, and multiplicity. And in the diagram, you see a new graphical notation of SysML v2. This relationship symbol means defined by. So the front wheel is defined by the part def wheel. By the way, in the background, all the other parts like body, battery, engine also have a type. It's a part definition from the library, which is automatically set in the background. Yeah, there are many, I would say, boring standard features of SysML v2. Something like model elements must be able to get a name. Well, that's part of the requirements for SysML v2 and this request for proposal. And SysML v2 shall provide a dependency relationship and shall provide a container for other model elements, so packages, and shall provide sequence, activity, and state machine modeling, and so on. So many standard stuff, of course, is also part of the list of requirements for SysML v2. Simply said, with SysML v2, you can do everything that you can also do with SysML v1. Of course, the concrete model elements are different, but you can do the same concepts. And everything you can model with SysML v1 can also be modeled with SysML v2 in 99% of the cases, I would say. Of course, there are very few exceptions on a very, very detailed level. So let's have a look on some new features that are not part of SysML v1. So SysML v2 will provide a capability to represent geometry, 2D and 3D geometry. So it's not the idea that SysML v2 is like a CAD model, but should be able to represent basic geometric stuff, which is systems engineering relevant. And of course, visualizations, also simple geometric visualizations. SysML v2 shall be able to provide capability to model risks. So that's part of the language. The integration of behavior and structure is much better in SysML v2. Other data structures are supported, like matrices and collections, which are not explicitly supported by SysML v1. There's a plan that there will be test cases for SysML v2 conformance, that some tool or model is conformed to the standard. SysML supports elements for analyses and tests. And very simple, but it's also part of the language and important, provide hyperlinks or navigation links between model elements. Now, most modeling tools already provide that. If you double click on an element in the tool, then you jump to another element or things like that. But that's not part of the SysML v1 standard. That's always tool specific. And here's the idea to put this into the language and to link to other internal, but also to external elements that you click on or that a part definition is linked to another model, a requirement to Polarion or whatever. Yeah, then that's also an important change. SysML v2 explicitly supports the modeling of variance. That's a challenge for many projects. That's already a challenge to model a single system, but most projects have variants of their systems, product lines and whatever. And SysML v2 provides at least these four concepts: variation points, variance, variability expressions. That's something like requires or XOR. And if you select this feature, then it's not allowed to have that feature. And so if you select the manual transmission, then you do not have the automatic transmission and so on. And the binding of variance too. So that's part of the language. That's very good. It's a good starting point. Here's an example of that. Again, my electrical vehicle. So you see it has a part front axis, and the part front axis has a part front wheel or two front wheels. And then we have a variation inside the wheel of the lug bolts. So we define that our front wheel has 6 lug bolts, and this could be the lug bolt 23 or the lug bolt 42. So this is a variation. So it restricts the variability here to 2 options. There's another area where SysML uses this mechanism more in the background, not so much visible to the user. It's an enumeration. Enumeration is it's like a variation. You have an enumeration of something, you have something kind, and you have 3 options. And only these 3 options are valid options. Well, that's the same principle. And in the background, it's the same mechanism if you use enumerations. In the diagram, it looks like this. Here we have this part structural tree here. And on the lower left corner, you see our lug bolt part, which has these 2 variants. So this defines the 150% model, or in the new ISO standard, it's called shared asset superset. And if you would like now to model a concrete configuration, then it looks like this. So you define a special version of your electrical vehicle. It's called this electrical vehicle feed 42. And then you, so to say, inject the Lv2 42 into this property. And of course, it must be a valid one. If you inject Lv2 71 or so, then it's not valid. Yeah, requirements modeling, also interesting area. SysML Lv1 already can do that. And SysML Lv2, it's a little bit different. For example, here you see requirement definitions. We can define requirements and we have requirement usages. So these are requirement definitions which could be used for requirement templates also. So we have a requirement definition of a battery capacity. Behind the doc statement, you see the requirement text. And then you can define attributes, whatever you like, and also constraints. Here we have two attributes, the actual capacity and the required, and must always less than. And similar to the maximum speed. On the second view, you see there is no concrete speed provided here, no concrete battery capacity. So these are definitions. And if you use it, and this is the diagram, sorry. If you use it here, then here we provide an identifier, which could also be provided on the definition level, but I skipped that. So it's here provided on the usage level, and we have the name e-vehicle battery capacity of this type. And then we set concrete values. Required is 50, and the actual one is a property from our system model. And the same for maximum speed. And then the tool, of course, can, on the model level, verify if this requirement is satisfied by the system model. At the top, you see a requirement group. The requirement e-vehicle specification defines that it requires these two requirements. That's a requirement group. And here's the graphical notation, which is not very exciting for requirements. It's a list of boxes. I assume in the same as for SysML Lv1, typically you use tables also to represent requirements. Yeah, then an example for activities. Here with the action charge battery. It has an in parameter power. And then we have, let's start with the first start. That's the initial node. And then we have the action insert charging block, then the action secure charging block. Then an action that has also an in value, a power, it's the charging, then the action unsecure charging plug, then the action remove the charging plug, and then done. Well, it's a very simple activity. At the top, this succession flow is an object flow. So that specifies that the input power value flows to the charge.power value, so to my action charge. And here's one more example. The remove charging plug action has an action definition. It's similar to the call behavior action. At the bottom, we have an action definition, which is empty. It's just there. And this action remove plug uses this definition. Okay, we also have a diagram for that. It's, well, in this case, it's okay, but because they are automatically created, they look often very, well, not very nice. Yeah, the interesting thing about activities is that the execution semantics is quite different than in SysML Lv1. In SysML Lv1, it's based on the token flow, if you're familiar with that. So the tokens flows through the diagram, so to say, following some rules. Excuse me, is there a question? Also, no. And here it's in the background, it's the same structure as in the structural area. So simply said, it's like an IBD. An action contains other actions. And with these succession or the then statements, we say what happens before and happens after. That creates the order. But in the background, it's the same foundation as for the structural level. So it's very easy then to combine them. And by the way, we use the same foundation also for state machines and for the interactions, the sequence stuff. Yeah, so it's very easy to then to integrate structure and behavior. Well, here on the left side, you see again our part electrical vehicle, and it has a port with a name and a type here, power import. The power import is specified at the bottom with a port def. Right? Very consistent. You have port and port def, part and part def, action and action def, requirement and requirement def, and so on. And the part vehicle also owns this action, charge battery, and then we have a flow, the flow of electrical energy from the port to the parameter of the action. So we can create flows from ports to ports, what you already know from IBDs and SysML v1, but we can also create flows from ports to parameters of an action, of a state machine, or whatever you like. So that's quite nice integration then. Yeah, and then that's a big task. SysML v2 will also provide a specification how to transform SysML v1 models to SysML v2. So then tool vendors, if they implement it, can provide this transformation that you create a SysML v2 model from your SysML v1 models. Of course, based on the specification, it's only possible if the SysML v1 model is conformed to the standard. So if you do not follow the rules, you cannot transform it. Maybe the tool vendors can build in some tricks, but of course you must be conform otherwise to the standard. So here we define mapping rules. A SysML v1 block is a SysML v2 part definition, and so on. Sometimes it's quite obvious, sometimes it's extremely difficult to map it. Yeah, and then the time, good on time, very good. Then we have this one more thing guy. It's quite simple to provide an API. SysML v2 will have an API, but this can be a real game changer. No? This is really a big thing that SysML v2 provides a standard API how to access the model. And access means you can read the model, but you can also change the model. You can create elements, update elements, whatever. And this is from the specification document. So there are two levels for this API. There's the platform independent level where the services and operations are defined, like get something, write something. And then we have a platform specific level with concrete bindings to a technology. And the standard will provide two bindings. One is a REST HTTP and the other one is OSLC. That will be part of the standard. But of course, other bindings will also be allowed, but they are not specified in the standard. Yeah, so with this API, where you can do the obvious use case. You have a SysML v2 modeling tool that provides the model data through this API. So any other engineering modeling tool, or also non-modeling tools, of course, can access the SysML v2 model. So this could be another SysML modeling tool, but can also be the CATIA, Windchill, Polarian, DOORS, but also tools like Miro, Excel, any tool can access it. For example, 1 or 2 years ago, I created a very, very simple prototype to create on a Miro board automatically cards from a SysML model. It reads the SysML model and created for every part definition a card on the Miro board. Or also I created a prototype to link Excel with SysML v2. It's quite easy. I'm not a programmer, but it cost me not much time to do that. Interesting is also another scenario, another usage scenario. So an Excel tool or Miro can provide this API, and then from the outside it looks like a SysML v2 tool. Of course, it's not complete, but you can query any tool through a SysML v2 API. Okay. That is also a possible usage scenario. For example, a SysML v1 tool with this API, with a built-in transformation, which is also part of the specification, then acts like a SysML v2 modeling tool from the outside. Okay, so yeah, still some time for the demo. That's very good. So I switch my screen. Or before I do that, I show you the next slide. So if you would like to use SysML v2, it's not finalized yet. You can use the pilot implementation. So the SysML submission team also creates a pilot implementation. That's necessary to demonstrate SysML v2 to others, to you, but also that we can validate our concepts. If it's only paperwork, well, that would be too hard. So we developed a pilot implementation. So the people, so a small team developed a SysML modeling tool. And you can download it for free from the SysML v2 sites. And then you can implement it in Eclipse, in the Eclipse plugin or Jupyter Lab. What I did is I created an open public service of the Jupyter Lab implementation of the SysML v2 pilot implementation. And you can access it through this link here, sysml2lab.com. And that's what I will do next. And I change my screen sharing. And here it is. So it's sysml2lab.com. And if you open that, then well, it looks like this. There's no login, also we trust the community. And it looks like the last one left the v2 lab. So it can look different with the open windows here. And what you see here is a Jupyter notebook. It's a mix of text. Here's pure text with some links. It's a markdown language. But also we have here embedded SysML v2 code. And I can execute this code. Now it's executed. And then I can visualize it. It's here. So it's a mix of SysML v2 code and text. So I can create here a new notebook. Let's go to this one, create a new one. And then we can start with part e-vehicle. Let's start easy. And it's correct. And then I can run the visualization statement, visualize it, which is not very exciting, but and we can create package around it. Demo part e-vehicle, part charger, connect e-vehicle charger. Correct? Yeah. Oh, Deno. Okay. Then a Deno, and so on. Oh, someone else also worked online. Yeah, you see, if you work on the same file at the same time, you can have these conflicts. So if you use it, you should not store files here that you would like to keep. No? If you wrote your SysML 2 code and you would like to keep it, then download it, because from time to time we restart the server and then everything is removed, and it's back to zero. So every month the SysML 2 team publishes a new version of the pilot implementation. That's, for example, one point in time when we restart the server. And then here the untitled notebooks are then gone. Yeah, that's the way you can use this one. Let's call it demo. And I can also show you the API. I can publish this model, which means now the model is published on a server. Oops. And the server is provided by Interkex. It's one of the companies that are strongly involved in the SysML 2 development. So now this simple model is on that server, and now we can access this model through the API, which is not very exciting through the user interface here. Let me think what the correct link is. It's something like this one with the docs. No. Yeah. So you can play around with the API through this Swagger interface here. It's really only a playing around with it. If you really would like to use it, you should write some scripts programming it to access it. But here you see the API methods. So you can get things, you can post things, you can delete things, and so on. And for example, I can get here the list of all projects on that server. Then you have to click on try it out. Sometimes you have to enter something, sometimes not. Here it is okay if to enter nothing. We can execute it, and then we get here, well, the output looks also not very nice. It's JSON. You see the list of projects on the server. They have an identifier and they have a name. It's here. And somewhere in there, name is Lv2 and yeah, that's February 9th. Yeah, that's our project here. Here it is. And then you can copy the identifier here. This is the project identifier. And then use this identifier here, for example, in this call, get projects by ID. And if you would like to try it out, then you have here an identifier. Yeah, then you have to enter it. It's not in my clipboard, sorry. Then I execute it, and then I get the result, and so on. And then you can dive more and more into the model. There are branches, by the way, and commits. So there's versioning in the model, which is also part of the of SysML 2. And finally, you can get the element of a specific project, of a specific commit. You get an element and can do something with it. Right? And then you get your electrical vehicle part and see how many wheels are in there. So this is just for playing around. But if you're familiar with programming of REST interfaces, you can access this the models then from your scripts. Yeah, so that's the Jupyter Lab environment. Of course, you can also implement it or install it locally, the Jupyter Lab, if you like, or in an Eclipse environment, but you can also use this one here. All right, cool. Let's go back to the slides. Yeah, and if you have any questions, would like to discuss things about SysML Lv2 or the pilot implementation, there's a Google group of the SST team, groups.google.com, and then it's SysML Lv2 release. So there you can ask questions, and most of the active SST members are members of this Google group and can then answer your questions. And that was the last slide.
Oh, great. Thanks, Tim. Very impressive. A lot to cover in a few minutes.
Yeah.
We have about 7 minutes left, and we have about 7 people have asked questions, and they have a number of questions. But I think if we let them pose one question to start with, and if that's okay with you who ask questions, just to put your microphone on and then pose the question. I'd like to invite first Alejandro Salado from University of Arizona.
Hello.
Hey, Tim. Thanks for the presentation. It was very useful. A question I've got is when you define the composition of a part as built by several parts, is the meaning of the relationship that the higher level part includes the other one, or is it really a partition where you have 2 hierarchical views of them, in the sense that the higher level part equals the aggregation of the lower level parts?
So let's go to this picture for it, but it's here. So
yeah. So for example, if you could have only 2 boxes, right? If you could model something as e-vehicle composed of a wheel, does it mean that the vehicle has 1 wheel among other things that you've not modeled, or does it mean that those 2 parts would be identical?
You mean the 2 wheels, if they are identical, or which one?
Oh, no. So yeah, no, let me change that. So when I look at that diagram, it can mean 2 things, and I want to understand what it means. It can mean that the vehicle includes those elements, okay? Or that the vehicle is the aggregation of those elements.
Oh.
Okay. So what is the meaning it's in version 2 when you make that diagram?
Yeah, well, that's a good question. And it's like in SysML v1, so it can be both. So the e-vehicle can still contain things that are not modeled. So it's not only the aggregation of the parts, could be more than this.
It could be more than that. Okay. Yeah. Okay, thank you.
Of course, I would say it's a best practice or a good practice that you should always do a complete decomposition and not keep parts in the node.
Right. Okay, thank you.
Okay, thank you. And if I was going to say this, that we'll go on for another 2-3 minutes, and then those that still have questions and still are able to stay on. I mean, Tim, do you have some minutes after this to stay on?
Yeah, that's okay.
Yeah, so those that have not maybe have emptied their questions can stay on, but I'd like to have one announcement before we close this session. Marcus Nordstrand, you had a question or 2 actually.
Yes, I had 2. The second one was about what types of relationships to other tools that could be done, and the answer I saw was, among other things, OSLC, which was my question. So I got the answer for that. Then I had a question on the variation point stuff. You use literals to define the variation names or whatever it's called. Are those names of the enumeration literals unique? Do they have to be unique according to the standard? Because I know, for instance, in Rhapsody, they need to be unique every time you define an enumeration literal, otherwise your model won't compile. So I just wanted to ask if there was something in the specification that said that kind one, the name of that string, of the string, so to say, needs to be unique with all the variation parts in the complete model.
So here in my enumeration, the kind one must be unique inside this enumeration. No? The enumeration something kind is a namespace, and everything inside this namespace must be unique.
Okay, so
but there can be other enumerations with the same name. That's possible.
Exactly.
In other namespaces, that's allowed, but not inside this one.
Good. That sounds good. Thank you.
Mm-hmm.
Okay, well, in interest of time, I'd like to maybe ask one question that was posed by Richard of Clint, which is has the tool vendors indicated a timeline for the SysML implementation?
No, unfortunately not. I know that some tool vendors work on implementations, but they're quite about that. So there's no public announcement. At least Spark Systems announced it, that they plan to support it, but without a timeline.
Okay. Thank you.
Mm-hmm.
I will steal the screen now just to make this final announcement, but those that still have questions, Jamie, Christer, Jakob, if you don't mind, hang on and we'll get to those. But I just want to share my screen. You can check those out on the INCOSE.se site. One is next one is one in Swedish, presenting what happened at the international workshop in the working groups. The other one will be on the 7th of April, which will be held by James Martin on the guide to the UIF. So again, one that's open for those are our international audiences. So with that, I'd like to thank Tim, and please hang on, Tim, and those that like to pose questions. This was an excellent introduction, I think, to what, and it's a big step, I think, modeling. So, all right, those that need to leave, and then those that I'd like to then maybe Jamie, Robis, are you still on and like to ask your question?
Yes, can you hear me?
Sure.
Yes.
All right, so thank you, Tim, for that great presentation. That was very informative. So my question is, now that SysML is moving away from using the UML meta model, what would be the mechanisms to ensure proper integration with software modeling?
Yeah, of course, that will not work the way it works now, where you can do the software modeling with UML and the same modeling tool as you do the systems engineering modeling with SysML. It's like any other engineering tool, like SysML to CAD, SysML to ECAD, SysML to requirements in another modeling tool, and then now you have SysML to software modeling, UML, for example, in another modeling tool. But there's not this integration we have at the moment.
Okay, all right, thank you.
Yeah, I think that was also the question that Jakob Eckerson and Johan Tegler posed on, unless anybody of those are still on, I'd like to add on. I think they left actually. So yeah, but that explains that one. Christer, are you still around?
I think Christer left us.
Yeah, and in the chat, I don't know if you see that. Actually, we have Jan Lin, right? You're still here, or?
Yes, thanks.
Yeah.
Hey.
Hello, team.
Hey.
Yes, thanks for the presentation. Just one question about the part you were showing. That is that, if my understanding correctly, so you can directly create an instance of a part without doing any part definition. Is that the intention? Yeah,
that's correct. And in the background, there's a part definition, but it's a very general part definition from the library. But it's typically not visible to the user.
Yes, but as the example shows that you use UCAV front view, rear view. So anyhow, you still need a kind of part definition like a block, but you just don't do that in the beginning. You create it when you need it.
Exactly, yeah. So well, it's up to you when you create a part definition. For example, if you would like to reuse things, then it makes sense to create it. But if you have only one engine, then it's not necessary. Then it's just one part engine with all the structure behind that.
So every time you actually, like in SysML 1, so every time you create an internal block diagram, you actually, here, you create it directly with the part. So you don't have several like internal block diagrams with different variations or.
If you have a part, you always need a context. Now, that's the same as in SysML Lv1. So here, in my example, you see on the screen is, still see it? No, you don't see it anymore. You saw on my screen, or you now see it on my screen. It's so the context for the part engine is the part e-vehicle, and the context for the part e-vehicle is not modeled here explicitly, but implicit in the background there is one.
Yep. All right. Yes, thank you.
So there are very common elements in the library, like anything, for example, is a library element.
Thanks.
Okay, is there anybody else online who has a question? There was actually some questions from Christer, but I lost the chat as I had was thrown out. So if you have access to it, Tim, and then we can at least get it recorded. If you look at Christer A, I think.
Yeah, Christer wrote, sorry, but I have to leave. So
yeah, I was thinking if you had his if you had the access to the chat, then reversed a bit into it.
So is hyperlinking supporting unique identification of an object in a model? Yes, so every model element has a unique identifier. So there was a discussion, but currently it's not shown in the textual notation because unique identifiers are not very nice to represent them, but they are in the model. It's there. So you have this unique identification. Then another question from Christa is V2 supporting migration of the graphical information in a diagram? How a part is positioned in a diagram in relation to another part, for example. And it's about the migration. So I think it's about migration from SysML v1 to SysML v2. Yeah, very likely, I think that the positioning, so the graphical information will not be transformed. Theoretically, it's possible because in SysML v1, we have this diagram interchange format. It's in the specification, but no one implemented it. So I don't think that we will provide a transformation of the graphical information.
Okay. Well, I think that emptied the bucket of questions. So with that, I really again thank you, Tim, for making this happening, and looking forward to SysML v2.
Yeah.
But what do you think? When will it actually be? When will it be approved by standards committees, etc.?
So I think we can do the submission for the 3rd quarter this year. It's tough, but I think we can do that. And then we have this deadline of 2 years for a finalization task force. That's part of the process at the OMG. And I'm afraid we need these 2 years. So it's a lot of stuff. And all the people working here in this team, this is not a full-time job. No? This is for most of the people on top. So in the evenings in the hotels. So, yeah, I think we need the 2 years for that. And when the finalization task force starts, it's also we also have then formal processes. Now, for every change, we need an issue, a voting, and so on. So it makes also the change process much slower. Yeah.
But we may see as tool vendors actually start adopting this before that. Then.
Yes, they can.
Yeah.
And if we look back in time, the switch from UML version 1 to version 2, the tool vendors were already ready when the OMG adapted it. So you got tools before the final publication was announced. So.
All right. Okay. Well, with that, again, thanks everyone, and looking forward to see you all again.
Okay.
Next time. All right.
Bye-bye.
Thank you. Bye-bye.
Bye. Thank you. Bye-bye.